Alright, so here we're going to look at chapter 6.7. So our essential question is, how can you define a sequence recursively? So we haven't looked at any recursive formulas yet, so that's what we're going to do in this section. So our learning targets. First we're going to write the terms of recursively defined sequences. So we're going to start by figuring out what the heck this word means. Then we're going to write recursive rules for sequences. Our third learning target is to translate between recursive and explicit. We've seen explicit rules for both arithmetic and geometric sequences, so now we're going to take those and go back and forth between these new recursive rules and the ones that we've already seen. And then we're going to be writing recursive rules for special sequences. So our core concept. Okay, so here we're talking both types of sequences that we've dealt with. We've looked at arithmetic sequences and we've also looked at geometric. So now we're going to find the recursive equations for both of those. So the recursive equation for an arithmetic sequence is right here. A sub n equals a sub n minus 1 plus d. So d is this common difference. And remember that the common difference is what I add each time. And remember, I could subtract too. Right, but that's what d is. It's what I add or subtract each time. So this really tells me that I take the previous term and I add this thing to it to get the new term. And then I take that term and I add to it and get the new term. So that's my arithmetic. So now my geometric, right? I've got a sub n, so my new number equals r, and r is the common ratio, and remember that this is what I multiply. Or divide, right? But we talked in the last video that dividing is really the same thing as multiplying by a fraction. So it's the same sort of thing. So this tells me that I'm going to get the new term equals that common ratio, that thing that I multiply each time, times the previous number, right? And we've seen both of these written in the different way, right? Written as an explicit term. So now we're looking at some recursive. So let's look at this example. This is going to be example number 1 right here. Okay, so I'm asked to write the first 6 terms of each sequence and then graph. So let's look at part A. Well, I'm told the first number in my sequence, right? And when I'm dealing with recursive rules, I always have to include the first term. And then I know that here's the rest of my formula. A sub n equals a sub n minus 1 plus 3. Okay, so now I can find the next 5 terms. So if I know my first term is 2, I can then plug that into my formula, right? And n minus 1, so the second one, my second term would be a sub 2 equals a sub 1, right, because 2 minus 1 is 1, plus 3. So I know my a sub 1 is 2, so I add 3 to that and I get 5. And then I continue my formula by adding 3 each time to get my next few terms. And then I'm asked to graph each sequence. Okay, so you'll see here that I've graphed each point. So when my x was 1, or my n was 1, right? My first term was 2, my second term was 5, my third term was 8. And you'll see here that I'm not going to connect these dots, right? Because this sequence is not a continuous not continuous data. Remember we talked discrete and continuous? This is discrete data. I don't have values in between. There's literally only these values. So I'm not going to connect the dots here. So now let's look at B. Again, I'm told my first term, and then I'm given my formula. Well, and I see here I'm multiplying, right? I don't have an add or subtract, so I'm multiplying. So I know that this is going to be a geometric sequence. Again, I know my first term, and then I go ahead and I plug that into my equation that I'm given to find my next few terms. And you'll see here I'm multiplying by each time. So my numbers get very large very quickly. And then I can go ahead and graph. And again, these are discrete values. I am not going to connect these lines, but you'll see that if I was to connect them, they would be an exponential function. Okay, so here's your monitoring progress. Go ahead and try these to see what you can come up with. So this right here is going to be example number 2, where we're going to be writing the recursive rule for each sequence. So before we were given the rule and we had to come up with the sequence, and now we are given the sequence and we have to write the rule. So the first thing we want to do is figure out what the pattern is and organize our thinking and our data. So we're going to write a table. So my n is going to kind of be this top part, right? And in our tables before we've used x, but this is your n. So my first term is negative 30, my second term is negative 18, my third term is negative 6, my fourth term is 6, and my fifth term is 18. So now that I have it written in a table, now I can try and figure out what the pattern is. So I see that between each of my values, I'm going to add 12. So when I'm adding, that tells me that it's going to be an arithmetic sequence. I know my first term, right, which is my a sub 1, is negative 30 because that's the first term in my sequence, and my common difference I found was 12. So then I can go ahead and write in what I know in my recursive equation. Okay, so I know I take my a sub n equals a sub n minus 1 plus d, and I substitute 12 for d. So here's my rule. So when I'm dealing with these recursive rules, I have to include this a sub 1. I have to tell my first term. Because if I just gave you this equation right here without telling you what my first term was, you'd never figure out what the rest of my terms were. Okay, so now let's look at b. So I do the same thing. I write out my table. My first term was 500, my second term was 100, my third term was 20, fourth term was 4, and fifth term was 0.8. So I noticed to get from 500 to 100, I divide by 5, right? And again, to get 100 to 20, I divide by 5. And that's the same thing as multiplying by 1/5. So I know that this is going to be a geometric sequence. I again know my first term is 500, and my common ratio is what I found is what I multiply by each time to get the next term. So then I can just plug in what I know, because here's my general recursive equation, and I plug in my r, and then again, for my recursive sequence, I have to give this a sub 1 value, or else I don't have enough information to continue on. So here is the recursive rule for this. And when we're writing these letters, remember, when it's a subscript, right, so below, which these ends are, that just tells me which one we're talking about. Okay, so here are some more monitoring progress, so go ahead and try these ones and see how you can do on them. Alright, so here is example number 3. So now I have to write an explicit rule for each recursive rule. So here I'm given the recursive and I have to go backwards to the explicit. So I'm given my first term and I'm given my recursive rule, right? So this one, this part A, tells me that this is an arithmetic sequence, right? Because I'm adding or subtracting. And my first term is 25, and I know that my common difference is negative 10. So I'm adding a negative 10 each time to get the new value. Okay, so then I can go back and look at my explicit rule for an arithmetic sequence, and we learned about this a couple of chapters ago. So look back in your notes if you can't remember where this is at. Right, so I have a sub n equals a sub 1 plus my n minus 1 times d. So now I just plug in the things that I know. I know that my first term is 25 and my common difference is negative 10, and then I simplify. Right, so 25 plus n minus 1 times negative 10. So I can go ahead and distribute this and simplify and then just write them how it is, right? And I see that I have some things multiplying here, so I would use the distributive property here and then combine like terms. So this is the explicit rule for this recursive rule. These are the same thing. They get me to the same place. So now let's look at B. So I know that this is a geometric sequence because I'm multiplying here in between, right? I see I've got a negative 0.5 times my a sub n minus 1. So I know that my first term is 19.6 because I'm told that, and I know that my common ratio, right, the thing that I'm multiplying is negative 0.5. So now I look back at my explicit rule for geometric sequences, right, and we just did this recently, so hopefully you remember this. I've got my a sub n equals a sub 1 times r, my common ratio, and here's my exponent is that n minus 1. So now I just plug in the things that I know. I've got my 19.6, which is my starting term, my first term, and my negative 0.5. And I can't do any simplification here, so I can just leave it just like this. This is my explicit rule for this recursive rule. Okay, so now we've gone that direction. So now we have some explicit rules and we have to write the recursive rule. This right here is example number 4 in your book if you're following along. Okay, so I can see that this first one is an arithmetic sequence because I'm adding or subtracting something. I know that my first term is when I can put in a 1 for n, so I end up with a negative 2 plus 3, so my first term is 1, and I know my common difference is negative 2. Right, and that common difference is always going to be this thing that I'm multiplying my variable by. So now that I have all the things that I need, I can go ahead and write my recursive rule. So I know my common difference is -2, and then to finish my recursive rule, I have to include what my first term is, right? My a sub 1 equals 1, and then I can write the rest of my rule. So now let's look at b. So b I can see is definitely geometric because I'm multiplying and I have an exponent. Both of those things tell me that I'm dealing with a geometric sequence. Okay, so now I first have to find my common ratio and my first term. So I know that my first term is when I put in a 1 for n, and 1 minus 1 is 0, and I know that anything to the 0 power gives me 1. So my first term for this sequence is -3, and my common ratio is 2. It's the thing that I'm going to be multiplying by itself over and over again. Well, so now that I have these, I can go ahead and plug in what I know in my recursive equation, which is that r value of 2, and then when I write my final recursive rule, I include this a sub 1 equals -3. So this entire thing right here is my recursive rule. I have to include both pieces all the time, or it's not a complete rule. Okay, so here's some more monitoring progress. Go ahead and try these. This is kind of your practice. So now we have our next example right here. This is going to be example number 5 in your book. So here we have to use this sequence that's shown, and then write a recursive rule, and then find the next 3 terms. So first I kind of figure out what's going on. So I want to find the difference and the ratio between each pair of consecutive terms, right? So I want to see what I'm adding each time and what I'm multiplying by each time. So I see that to get from 1 to 1, I add 0. To get from 1 to 2, I add 1. And then here I add 1. So since these are not the same, I know that this is not an arithmetic sequence, right? Because if it was arithmetic, all of those would have to be the exact same. So now let's look at my ratio. Okay, so I know 1 times 1 is 1, but if I multiply here, I have to multiply by 2. Now if I multiply again, I have to multiply by 1.5. So this ratio is not common. It's not the same, so it's not a geometric sequence. So this tells me that it's just another special type of sequence. So now what I'm going to do is I'm going to find the sum of each pair of consecutive terms. Okay, so I'm going to take a sub 1 plus a sub 2. And that is my third term. So then I see a sub 2 plus a sub 3. That gives me the fourth term. And then I add, and that's the fifth term. And I continue on adding the previous 2 numbers. So beginning with the third term, right here, each term is the sum of the 2 previous terms. So to get the third term, I add 1 and 2, the first and the second. To get the fourth one, I add the second and the third. And I continue on and continue on. So a recursive equation for this sequence is something like this, right? I find my new number, my a sub n equals a sub n minus 2 plus a sub n minus 1. So this tells me that I take the term that's right to the left of me and the term that's to the left of it, and I add those 2 together to get my new term. So that's my recursive rule. Okay, so again, when I write my final recursive rule, I have to tell where I start. I need my a sub 1, but I also need my a sub 2 because I have to know the first 2 terms of where I start in order to get to the next and the rest of my sequence. So now I can use my equation to find the next 3 terms. Right? So I know that I take the 5th term and the 6th term and I add them to get the 7th term. Then I take the 6th term and the 7th term and add them to get the 8th term. And then I take the 7th and 8th and add them to get the 9th term. So these are the next 3 terms in my sequence. And I can continue on and continue on and continue on doing that. So now we've got a couple more monitoring progress, right? This gives you that chance to try and figure out what's going on with these terms, with these sequences, and how I can write rules for them. So please try these and see how you can do. And then it's time for you to work on your homework. So let's go back and look at our learning targets. So can I first explain what a recursively defined sequence is and kind of write it out and explain it? And then can I write the terms of that recursively defined sequence? Second thing was write recursive rules for sequences, right? And we did that when we were given our sequence and we had to come up with what's happening. We looked at 2 examples of translating between recursive and explicit, and then we saw some explicit ones and had to go back to recursive. So examples 3 and 4 really talk about this learning target and help us get there. And then that example number 5 we looked at, we had a special sequence. And we'll get more into special sequences later on in math and talk about what specific sequence that one was that we looked at in the example. But we had a special sequence and we wrote a recursive rule for that. So we met all of our learning targets going through these examples. So now I want you to go ahead and log in and start working on your homework for 6.7.